Hello everyone, my name is Phatteera Kalmapijit or Ernie. Today I'm gonna talk about electromagnetic induction. What is electromagnetic induction? It is a process where a conductor placed in a charging magnetic field causes the production of a voltage across the conductor. This one is magnetic lines of force. If the wire is then wound into a coil, the magnetic field is greatly intensified, producing a static magnetic field around itself, forming the shape of a bar magnet, giving a distinct north and south. The magnetic flux developed around the coil being proportional to the amount of current flowing in the coil's winding, as shown. If additional layers of wire are wound upon the same coil with the same current flowing through them, the static magnetic field strength would be increased. Therefore, the magnetic field strength of a coil is determined by the ampere turns of the coil. With more turns of wire within the coil, the greater the strength of the static magnetic field around it. But what if we reverse this idea by disconnecting the electrical current from the coil, and instead of a hollow core, we place a bar magnet inside the core of the coil? Inside the core of the coil of wire, by moving this bar magnet in and out of the coil, a current would be induced into the coil by the physical movement of the magnetic flux inside it. Discovery of electromagnetic induction. The first one who discovered of electromagnetic induction was Michael Faraday. Is given credit for the discovery of electromagnetic induction in 1831. Faraday noticed that when he moved a permanent magnet in and out of a coil or a single loop of wire, it induced an electromotive force or EMF, in other words, a voltage, and therefore current was produced. So what Michael Faraday discovered was a way of producing an electrical current in a circuit by using only the force of a magnetic field and not batteries. This then led to a very important law linking electricity with magnetism, Faraday's law of electromagnetic induction. So how does it work? Faraday's famous law of electromagnetic induction states that a voltage is induced in a circuit whenever relative motion exists between a conductor and a magnetic field, and that the magnitude of this voltage is proportional to the rate of change of the flux. Well, this is determined by the following three different factors. The first one is increasing the number of turns of wire in the coil. Second one is increasing the speed of the relative motion between the coil and the magnet. The third one is increasing the strength of the magnetic field. Faraday's law of induction also have a formula. EMF equal minus N and delta flux over delta T. This sign stands for EMF, electromagnetic field. N stands for number of turns, flux. This is called magnetic flux. And this one is T stands for time. So I'm gonna show you guys an example. The magnetic flux passes through a 500 turn coil is reduced from 4.0 times 10 to the power of minus 5 WB to 2 times 10 to the power minus 5 WB in 0.02 seconds. What is the average induced EMF? So the given is N equal to 500 and delta flux 2 times 10 to the power of minus 5 because of 4 times 10 to the power of 5 minus 2 times 10 to the power of 5. So you get this one, and delta T is 0.02 seconds. So we will use the given in the formula. And when we have finished calculating the number, and so we've got 0.5 volt. Another topic is Lenz's law. Faraday's law tells us that inducing a voltage into a conductor can be done by either passing it through a magnetic field or by moving the magnetic field past the conductor, and that if this conductor is part of a closed circuit, an electric current will flow. Lenz's law states that the direction of an induced EMF is such that it will always opposes the change that is causing it. Thank you.
And today I'm going to talk about magnetic flux. What is magnetic flux? Magnetic flux is the number of lines of force that pass a given area. This one. This is given area, and this is magnetic flux. This is a symbol of magnetic flux. And the unit of magnetic flux is Weber. The magnetic flux that passes through the surface is defined to be the product of the magnetic field and the surface areas, and this is the formula. Magnetic flux is equal to magnetic field times surface area. B is magnetic field. Unit of magnetic field is Tesla or Weber per meter square. A is area. Unit of area is meter square. Magnetic flux per unit area is often called magnetic flux density. Let's do some examples. Okay. Example 1. A circular coil of area 100 cm square is normal to a magnetic field of 0.2 Tesla. What is the magnetic flux passing through the coil? First, we have to write given. It's already gave us area magnetic field, and they want to know what is magnetic flux. Area is 100 centimeters square, and magnetic field is 0.2 Tesla. What is magnetic flux? We use this formula, but first we have to change centimeter square to meter square. So we got 100 times 10 to the power of negative 4 meters square, and we use this formula again. Magnetic flux is equal to 0.2 times 100 times 10 to the power of negative 4, and we use calculator to calculate. 0.2 times 100 times 10 to the power of negative 4. The answer is 2 times 10 to the power of negative 3. And the unit of magnetic flux is Weber. This is the answer. Another example. Example 2. What is the area of a circular coil that is normal to a magnetic field of 0.5 Tesla, which is passing through the coil by a magnetic flux of 3 times 10 to the power of negative 4 Weber? First, we write given. They want to know what is the area. And they already give us magnetic field and magnetic flux. So we use this formula again. 3 times 10 to the power of negative 4 equals to 0.5 times area. Use this to move this to divide. So 3 times 10 to the power of negative 4 over 0.5 equals to 3 times 10 to the power of negative 4 over 0.5. The answer is 6 times 10 to the power of negative 4. The unit of area is meter square. This is the answer. Thank you.
Hi, in this video I will be talking about electric generator. Electric generator is the device that converts mechanical energy into electrical energy. Sources of mechanical energy includes gas turbines, water turbines, or steam turbines. For example, dam and coal power plants, which they will use turbines to generate mechanical energy. It was first built in 1831 by Michael Faraday. So, how the electricity is produced? We have to first understand the electromagnetic induction, which Ernie has explained it already. So the generator is based on electromagnetic induction, which is the change in flux of the coil which will induces electric current in their circuit. So here in the diagram you can see this is the North Pole, this is the South Pole, and this is a circuit which is a coil and is rotatable. So for electricity to occur, we have to put motion on this coil. So we have to make this coil to turn this way. So if we turn it this way, the electricity will flow this way and out this way. And this is because the magnetic field, the line that travel from North Pole to South Pole. And here in the green region, the current flow upwards, as you can see, but when we flip, the current will go downwards, and this will reverse with the yellow region. This will come to AC generator or alternative current generator, which is the simplest to explain. It consists of a rotatable coil together with the two rings and an outer circuit. So first, this coil needs to be rotated. So we assume that there is an axis connected with a turbine, and also magnets are required both poles. And so assuming the electric current runs this way, it will the current direction will be this way out and go like this, and when this coil is turned another way, this circuit in orange will alternate. From it's going this way, it will going that way. So this kind of generator, if leave the coil to rotate, so assuming this is clockwise, this circuit in the orange will keep alternating. Now comes to DC generator or direct current generator. The difference between the AC and the DC is the AC has these two rings connected with the outer circuit, while DC consists of a split ring commutator, which it makes this circuit, the orange circuit, goes with the direct current. So imagine that this coil turn 90 degrees, it will not produce any kind of current. So the commutator is split on the top and the bottom, so when the coil is turned again, it will still continue the current in the orange, the direct current, while this is turned again and again and again, and this will be always direct.